I just want to use this video to show you how to use the yield function in Excel. So here I have a sort of a coupon bound situation. You can see the some characteristics of the bond. The face value typically is $1,000. So here is 1,000. And bond price is $1,060 and coupon rate is 6.35% and frequency payment is 2 times per year. So that's like the most popular case. And current date. So this is also called the settlement date. So this is like the date that I posted this Excel file, which is September 12th, 2023. And maturity date is like 10 years from that date. And you can adjust this date later. And actually, that's one benefit of using this yield function is that it's not bounded to sometimes using the integer numbers of the number of years until maturity. So you can just, for example, change this to be October the 25, something like that. So now let's use first. Here I'm showing you 2 ways to calculate the yield to maturity. The first way is use the yield function. So just type equals yield, open, and now you can see different arguments here. So settlement. So this is the settlement date. So that's basically the current date here. And then the maturity. By the way, do not hard code the data in when you use the Excel function. Here you can notice that I always use the cell value, cell reference instead of directly typing the cell value, right? Because that's actually one benefit of using the Excel function instead of doing the calculation, for example, in your calculator, because you can easily change the cell value and the calculated yield to maturity will automatically change. So the second argument here is maturity. So that's basically we click here and continue read. So this basically is the coupon rate. So we do need to put this as a percentage rather than, because sometimes if you use, for example, a financial calculator, you may just accept a value of 6.35 instead of 6.35%. But here you do need to input the entire coupon rate, the valid coupon rate, not just the portion of the fraction without the percentage symbol. So the next argument is PR. This stands for the price. So notice here the price and the next argument, which is the redemption, or needs to be as a fraction of the par value. So redemption typically is the par value. So the par value to itself as a fraction, basically that's 100%, right? So in this case, we actually don't need that percent, that fraction. We just keep the number without the percent. So that means in order to convert the price as a fraction of the redemption, which is the par value or the face value, we simply can divide the price, right? The price, which is here, that divided by the face value. But if I just leave it like this, it will just be a ratio, right? But again, and it will be just some 100%, something like that. But I don't need that percent. I don't need that percent symbol, right? I just need the number without the percent. So in order just to get a number without percent, I can just multiply by 100. So, and then that's the PR, and redemption, that's basically my par value. So again, here I just input 100 because the par value as a fraction of itself is 100%, and I just kept 100 instead of having the 100%, right? So then the next argument is the payment frequency. So here I'm just putting this as 2, right? And we don't have to worry about the basis here. That stands for the, for example, whether how many days are there in a month, things like that. So we just follow the default. And then we can close this function. And once you do that, you can see this would be 5.57%. So using the yield function. The other way we can get the same value for the yield to maturity is to use the read function. You can see here I just so let me just use this to do the calculation again. But to use the read function, notice here the yield function, I don't have to do any manual calculation. Maybe the only exception is the price, right? Because I do need to use the price as a fraction of the settlement, as a fraction of the settlement price or the par value. But to use the read function, I will need the yields to maturity, this number. So that's why here I calculate this. So basically this can be calculated by taking the difference between these two dates, maturity date and current date, and then divided by the number of days in a year, right? So sometimes you might want to use 360 rather than 365, because that seems to be the convention of the some calculations. But here I just use the number of days within a year. This should give you pretty much similar or very close numbers. But again, this is not as accurate as the yield, using the yield function, because yield function, we don't have to do any manual calculations to convert the two dates into the number of years, right? But here we do. But as you can see, because of the choice that we can have for the number of days within a year, so that can also give us some slight difference for the results. So let's continue. Once we have that, so I can use the read function. So equals read, then open. Now you can see the read function has sort of a different set of arguments. First, this is NPER. So this stands for the number of coupon payment. So we can calculate this by the number of years and then multiply by the frequency for the coupon payment, right? So this is like an approximate. So PMT, this stands for the payment. So payment here, we do face a choice because the rule to use the read function here is that the next argument is the PV, that stands for the present value or the price, and the next argument is the future value FV. So the rule here is that the PV and the other two numbers, PMT and the future value, they have to be in opposite signs. In other words, you can either make PV to be positive and then make the PMT and FV to be negative, or you can just take the other way around, make the PV to be negative and then PMT and FV to be positive. So here I choose to make the PMT and future value to be positive. So PMT stands for the coupon payment. So here we do have to be careful because the coupon rate stands for the annual coupon rate. So once we multiply this by the face value to get the coupon payment, this is the annual coupon payment. So we do need to divide this by the number of the payment frequency. Right, so that stands for the sort of a semi-annual coupon payment, because everything here needs to be in semi-annual format. So that's why here I also multiply the number of years by the frequency for the coupon payment, which is 2. So that stands for the number of semi-annuals here. And the next argument is PV. Again, we have to be very careful. Once we have chosen to make the PMT and FV to be positive, I have to make this PV to be negative. And if you don't, you get an error message from Excel. So PV here is basically the present value. So unlike the yield function here, which I do need to convert the price to be as a fraction of the face value, here I can just use the absolute value of the price. So just click on the cell reference and then continue. The next argument is FV. So this has to be in the same sign as the PMT. So, and then just click on the face value here. So we don't have to worry about the other arguments because they are optional. So once I have this, but then we are not done yet. So that's why using the read function here might be a sort of needs more careful consideration, because the rate we got so far stands for the semi-annual rate, semi-annual yield to maturity, because everything here is the semi-annual format, right? So, and then we are interested in the annual yield to maturity. So now I do have to convert this back to the annual yield to maturity by multiplying this by the payment frequency. So once I do that, you can see now this number will be approximately close to the number we got here. But once you increase the number of decimal places, you can see that there's still some difference, but the difference might be small. Right? Once you, for example, I increase this to be this much of the, and you can see there's actually some difference there. And again, the difference is driven by the factors that I talked about earlier. So I hope this video can help you to master how to use either the yield or the rate function to calculate the yield to the maturity using Excel.